Modern medicine is built on a specific foundation. Isolate a single, highly purified active ingredient to target a specific biological pathway. But cannabis creates a paradox. When patients are given a synthesized, purified THC pill, like Marinol, they frequently report less relief and more intense side effects than they experience with a crude whole plant extract. In 1998, researchers Ben Shabat and Meshulam published a theory to explain this discrepancy. They called it the entourage effect. The core logic suggests a biological synergy where 1 + 1 is greater than 2. This explains why two plants with the same THC percentage can produce polar opposite experiences, one acting as a sedative while the other triggers a panic attack. Today, the cannabis industry treats this synergy as established fact. However, strict clinical pharmacologists remain skeptical, often viewing the concept as a convenient marketing narrative rather than a proven medical reality. The infrastructure for these interactions is the human endocannabinoid system. It relies on a network of receptors, specifically CB1 in the nervous system and CB2 in the immune system. Most pharmaceuticals aim to hit a single receptor with a highly refined active agent. Cannabis takes a broader approach. In addition to primary compounds like THC, the plant produces over 120 minor cannabinoids and a class of bioactive molecules called terpenes. These components exhibit pharmacokinetic synergy, changing how the body handles drugs. For example, myrcene increases blood-brain barrier permeability, allowing THC to enter efficiently. There is also pharmacodynamic synergy. CBD physically alters the shape of the CB1 receptor, decreasing the anxiety-inducing signals typically sent by THC. Meanwhile, minor cannabinoids like CBG target entirely different cellular nodes. These simultaneous chemical contacts trigger apoptosis, forcing malignant cells to break down and die. These overlapping biological mechanisms demonstrate that botanical mixtures behave with a complexity that puts them in a different category than isolated synthetic compounds. If this synergy is biologically plausible, why is it so difficult for standard clinical trials to definitively prove it? The hurdle is the sheer scale of data. Mapping a single extract's complexity requires high-performance liquid chromatography, or HPLC, identifying nearly 100 compounds in a single run. Scientists interpret these interactions using a combination index. Data points below the baseline indicate synergy, while those above represent antagonism. A precise 1-to-1 ratio of CBD to THC falls deep into the synergistic zone. However, a 1-to-4 ratio suddenly spikes into antagonism, reducing overall effectiveness. This sensitivity to exact ratios makes botanical mixtures an immense challenge for clinical researchers. When a minor shift in the formula can flip a treatment from effective to antagonistic, standardizing a trial becomes a logistical nightmare. Clinical trials are traditionally designed to validate single-molecule drugs. They aren't built for botanical mixtures, where dozens of active compounds can fluctuate based on light, soil, or genetics. To solve this, the medical industry is moving away from scientifically vague marketing terms like indica or sativa. The shift is toward chemovar indexing. This system maps exact cannabinoid and terpene profiles to specific medical outcomes, such as inflammation relief or seizure management. This indexing provides a bridge between anecdotal patient experiences and modern clinical data, turning decades of individual observations into a predictable, measurable framework. The entourage effect shows that a therapy's success can depend as much on the interaction between molecules as on the molecules themselves. Deciphering these botanical relationships provides a new roadmap for the future of complex, multi-target medicine.